Now, yesterday means the last time you were here, we worked on just some basic, review. I'll go over that again, just kind of feed into what we're doing today. I don't know what this is. PowerPoint. I don't need that right now. I just need the whiteboard. There we go. Review over line segments and lines. And the intersection of those two lines form an angle. It comes up. Okay. We went over line segment. We went over array. We didn't go over it. You read it in the book. And a line. And we talked about how an intersection of those three things form an angle. We talked about what kind of angles. We talked about a right angle, which means what? 90 degrees. We talked about an acute angle. Good. Were you listening? I'm not used to that. Less than 90 degrees. You were listening? Oh, you wasn't? Okay, we're good. That makes me feel better. Obtuse. More than 90 degrees. And straight. And I'm a George Strait fan, so sometimes I have a hard time spelling straight. So I said, sometimes I spell it like that. Doesn't have a G in it? G-H-T, isn't it? Well, I spell it as George Strait, so I-G-H-T, and that's equal to 180 degrees. All right. And we also discussed complementary, which means equal to 90 degrees, and supplementary, which is equal to 180 degrees. And we talked about radians. Now, one thing that I need to re-stress on the radians, because one radian is basically, I like to call it, is equal to somewhat of an equilateral triangle. All right, think of it like that. Okay, you got a circle, and you got a radii, a radius, and you got that radius here, but you can't have this right here is what I call the chord. Okay, but the chord is not what's equal to the radius. The curve is equal. So that curve, that arc length is equal to the radius. Okay? So this is 1 foot, and this is 1 foot, and that curve is 1 foot. And that's what a radian is. Okay? And we also talked about if you wanted to convert from degrees to radians, then you got to put 45 degrees over 1. Okay, that's nice. I don't know where that came from. Okay. Times pi over 180. And why did I use 180 on the bottom? So that leaves the cancel. And that leaves you with 45 pi over 180, and you reduce that down to what? Pi over 4. I think it's pi over 4. Somebody check it. No. Pi over 4. Okay. It's all I heard. Okay, and then if you have 3 pi over 2, then you want to change that, then you multiply by 180 over what? Because you want pi's for what? Cancel. Two cancels with that. 90. 3 times 90 is what? 270 degrees. Okay, we talked about that. Let's see, what else did we talk about? There's one more thing that I'm missing. Oh, going from degrees, minutes, and seconds, which is pretty much useless. But anyway, 24 degrees, 32 seconds, 32 minutes, 42 seconds. You want to change that to decimal degrees. What do? By 3,600. Okay, so multiply by 60, then multiply by 3,600. And then if you go the other way, 27 degrees, 27.1329 degrees, you multiply by 60, right? And then you multiply. One of them you divide and one of them you multiply. Look right quick. I can't remember. 160 and 60, and the other one's is one that you multiply. I believe this one you divide by. Y'all check it. Okay. So you take 0.13929. Since this one is the one you're going to use the most in the real world, you're going to change this one into degrees. 0.1329 times 60. Somebody do that and tell me what you get. Seven 0.4974. 7.977. So that's 07. So that 07 would go 27 degrees, 07 minutes, and then take that 0.974 and multiply it by 60. And what do you get? 58.44 to 58. It's funny that you have to do that. 58 minutes or seconds. Okay. So I think we covered most of that, and I think we covered some adding and subtracting of angles, which y'all should know how to do that. Okay, if you don't, then send them in and we'll go over them. I'm going to wait until I cover 2 sections because they tie in together, and then we'll look at homework. Okay? All right, so what do we cover today? Well, we're going to cover today, Oscar had a hunk of apple, pretty much. Oh, one more thing we did cover. Make sure you can do the unit circle. Okay, I'm just going to cover the first quadrant of the unit circle. Okay? You always want to start with the first quadrant. And all you got to remember is this is 0 degrees and 360 degrees. And this is 90 degrees. And then this is 30 degrees. This is 45 degrees. And this is 60 degrees. And then to figure out what that is, take this over 1, multiply by pi over 180, 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 and then you'll get your radians. And then you just extend those out. and start calculating, subtracting, or adding to 180 and 270, start however you want to do it, and you'll get the rest of the unit circle. Make sure you can do this in less than 2 minutes. So that way when the test starts, you can draw this first of all. Yes, sir.
Like, wasn't there like some kind of
We're going to cover that today, if you'll let me get there. Can I be in charge for a while? We'll cover that today. Okay? Yeah, that's when you talk about the special angles and the sine, cosine, and tangent of the special angles. Okay? So make sure you can do the unit circle, and then after you do a nice unit circle for your notes and for your test, then we'll add the sine and the cosine to it, and then you'll have it ready for the test. So what I would suggest you do is make sure you make this in a nice, take a piece of printing graph paper or printing paper, which is real white, and draw a unit circle. Take a big coffee can maybe and make a nice unit circle and do it right with rulers and straight edges. Take some time to do it. And then as we go along, put all this stuff on there, so when we have the first unit test, you won't have to redo it, it'll be right there for you. Or, I know this is tough, you can go to Google. You know, this might be tough. You'll have to push a couple of buttons, and you'll have to, what's that thing that you get stuff out of the printer? You have to print it. Yeah, that takes quite a bit, you know. Some of y'all might not be able to handle it. Can y'all read sarcasm okay? Okay. Just type in unit circle. Look over there. And then you can print that out and, you know, print that out if you want to. But like I say, when do you learn the best? When you understand what it is. Okay? Regurgitation means squat. You've got to know what it is. After you learn what it is, then print one of these up just so you can have it real nice and neat on your test when you need it, if you need it. But by the time I get through with teaching you how to do it, you should be okay. You shouldn't need it. All right? Now, in trig, we're going into 8.2 now. In trig, you basically revolve around sine, cosine, tangent. This battery must be going there. Yep, that's it. Okay. A whole year I had this phone right here, and I'm about to pass out. I need an ambulance. No, I need a battery. I'm gonna send somebody down there to get a battery. Please. The AAA to go in the marker on the system. You know, the marker. I appreciate it. Thanks. Bye. Jennifer or Logan, when y'all go down there and get it for me? Battery? Just go down the front desk. Yeah. Triple. No, it's a double one. Here, take this with you. It's blending. Thank you. All right. Sine, cosine, tangent. Cotangent. Secant. And cosecant. Okay? Now, I'm going to teach you the way that I was taught. Now, if I don't teach it the way you learned it, if it ain't broke, what? Don't fix it. I don't need anybody telling me that they don't know what Oscar had Uncle Papel meant. Okay? If you don't know what that means and you know it about another way, then you do your Sokotoa. Okay? I don't need somebody saying, well, I don't know what Oscar is. I don't know what that is. Shut up. You know exactly what it is. All right? Oh, good people. Irritating me. Oscar had a hump of apples. Now, somebody tell me what the relationship is with these three to these three. As I remember from pre-cal. I'm going Oh, some of y'all did. What's that called? The what? Reciprocal. So, apple of. This one goes with this one. Hump A. Oh. She didn't fuss at it. She what? Oh, okay. Had Oscar. Now, what the heck do those mean? Well, anytime you got a right triangle, there's going to be an angle. Okay, it's going to be called theta. Theta is Theta. Across, well, you put your little man on theta. Here's a little man, because that's you. Okay? The little man is on theta. One of his feet will always be on the what? Hypotenuse. And one of his feet will always be on what? Adjacent. Therefore, he's always looking at the opposite. Now, I was taught, and I kind of finagled it and kind of, what do you call it when you revise the way I was taught? And I came up with the little man, and I came out with looking at the opposite and one foot on the hypotenuse. I came up with the little man myself. Okay? When you've seen it, then that means somebody else came up with the same idea I did. It's nothing that big a deal, okay? But if you use this, whenever you know where theta is, you won't have to memorize anything. Okay? You won't. Because if you want the sine of this triangle, you just take the opposite and put it over the what? The hypotenuse. Opposite over hypotenuse. Adjacent over hypotenuse. Opposite over adjacent. Whatever those numbers are, you're going to put them in. Everybody with me? Okay. Never fails. You just told me the whole thing was approved. Hold on a minute. Just give me a second. There. Now you're approved. There. Now, there's three angles that I told you about. One is 30 degrees. One is 45 degrees. And one, no, I don't do that. And one is 45, 60 degrees, which is the opposite of this one right here. Yeah, I know, I just got to stop. There. Now, each one of those special angles have a measurement on them. The easiest one to remember, anybody know which the easiest one to remember is? Any carpenters in here? 45. 1 foot this way, 1 foot this way, you draw a line, that's 45 degree angle. Carpenters use it all the time. 1 square root of what? Square root of 2, which is 1.4. That's the easiest one to remember. Now, the other two have these three numbers. 1, 2, square root of what? 3. And all you have to remember is which one is the longest side. Which one is longest? 1, 3, I'm sorry. 1, 2, or the square root of 3? 2 is your longest side. So that means 2 will go right here. And 2 will go right here on the what? Hypotenuse. So now you just match up the shortest side. What's shorter, 1 or 1.3? I'm sorry, 1.7. 1. So this is 1. This is square root of 3. This is square root of 3. And this is 1. Now, do you see why I'm telling you you don't have to memorize this stuff? You don't. All you have to do is learn it. And it's based off of the 45 degree angle. 1, 1, 2. And then all you got to throw in after that is what? The square root of 3. And then you start putting where it needs to be. But if you try to go through and memorize this stuff, it's kind of like eating a cracker when you're starving. I'm talking about saltine cracker for those of you who don't know what a cracker is. Saltine cracker. It'll last about how long? 10 seconds. And then, okay, I ate that saltine cracker, I'm fine. 10 seconds later, you're hungry. Same thing with regurgitation. Regurgitation, and y'all have all done it. I have done it. I have to do it with phone numbers. I have to sit there and I have to do phone numbers over and over in my head. And by the time I get to the phone, I still forget the phone number. I have a short-term memory of -10. Okay? My long-term memory is very good. My short-term memory sucks. All right? Some of you both suck. All right? Some of you have a photographic memory. Okay? If you, oh gosh. I'm going to talk about my exes now. My ex-in-laws. All 3 siblings. All 3. Photographic memories. Photographic. Is that what you call it? Photogenic or photographic? Mm-hmm. Photographic memories. All 3 of them could have went to school and made A's. Did any of them go to college? Nope. It's wasted. It is. They could have all 3 been doctors, lawyers, physicists. They could have been anything they wanted to be because they had the magic of photographic memory. I would give anything to have, not anything, but it'd be nice to have that. I can't remember a phone number. And your name, forget it. I can remember a face, but I can't remember a name. It's awful.
Oh.
Huh?
Oh.
What?
Oh.
No, it was that way when I was at Clemson. I had to really struggle to get my math degree at Clemson because I had to study 3 times as much as students that had some kind of memory. And some of y'all are like that. Some of y'all can't remember a phone number. So if you can't remember a phone number, you can forget regurgitation on this stuff. You're going to have to learn it. Period. Okay. So I want you to fill out the sine, cosine, tangent, cotangent, secant, and cosecant using those 3. And just do this. I'll tell you what. You don't have to. Okay, this is, I want you to do it, but I don't want you to use it as a cheat sheet. What I want you to do, I can remember how to use the eraser on this thing. I want you to make 3 columns. 1 column, 2 columns, oops, doesn't matter. 2 columns, 3 columns. Call the first one 30 degrees, or 45 and 60. And I want you to write each one of these out on each one. So your little man on the 30 degree is going to be right here. And his foot is on the what? The hypotenuse and the what? Adjacent. And he's looking at the opposite. That's an O, not a 0. Okay? This little man is on the hypotenuse and the adjacent. And he's looking at the opposite. And this little man is on the hypotenuse and the adjacent and looking at the opposite. And some of y'all that's had the algebra pre-calculus before is going to fill this chart out and you're going to say, I can't believe it's that easy. And it is. In 7th grade, I had one of the worst teachers in South Carolina as a teacher. Her name was Brenda Bradbury. She was so mean that somebody actually put a fish on her engine of her Lincoln Continental. It ruined the car. She had one of those big tanks. Let me see if this is Stephen. Yeah, hello. Free this, free that. Okay, what was I talking about? Anyway, she ruined my math career from the 7th grade on. And there are teachers out there like that. Now you're also going to have to memorize to rationalize the denominator too. If you can't do that, then you pretty much failed. So, what is the sine of 30 degrees? Will that be opposite over hypotenuse? 1 over what? 2. 45. 1 over square root of 2, which is equal to square root of 2 over what? 2. Because you got to rationalize the denominator. Opposite over what? Hypotenuse. Square root of 3 over what? There you go. Adjacent over hypotenuse. Adjacent over hypotenuse, square root of 3 over 2. Adjacent over hypotenuse, 1 over square root of 2, which is equal to square root of 2 over 2. Adjacent, 1 over 2. Opposite over adjacent. Opposite over adjacent. 1 over the square root of 3, which is equal to the square root of 3 over 3. Opposite over adjacent. I'll do that one for you. 1. Opposite over adjacent, square root of 3. Now, you might want to put a 1 there so you can flip it for cotangent. Now, fill out the cotangent, that's all you do is what? How many teachers, if you've had pre-cal, have told you to memorize this chart? You don't have to memorize it. All you got to do is learn it. So, cotangent is going to be square root of 3 over 1. 1 over square root of 3, which is equal to the square root of 3 over 3. Secant is going to be 2 over the square root of 3, which is equal to 2 times square root of 3 over 3. Square root of 2 over 1, which is square root of 2. And what about this one? I think I did that right. That does not look right. Somebody check that one, make sure I did that one right. Yeah. Okay. Just didn't look right. Something. Okay. Not sure that. Square 2 is 1, 2 is 1. Cosecant is the sign, so that'd be 2. Cosecant here would be 2 square root of 2 over 1, or square root of 2. And this would be 2 over square root of 3, which would be 2 square root of 3 over 3. So what should you memorize on this page? Those 3 triangles. Because if you memorize the 3 triangles, you won't have to memorize the chart. You just have to fill it out whenever you need to. Now, of course, you can go to Google and Google special angles, sine, cosine, special angles, and you can pull up a nice one if you want to. Okay? Question, gripe, complaint. I thought we had a couple of people who had pre-cal in here. I know of 1, 2, 3. So, do y'all remember this? Did you have to regurgitate it or did you learn it? Regurgitate it. Huh? Who was it? I don't believe I knew him. Yeah. Now, let's talk about, well, this is a little bit about what we're going to talk about. This is distance formula, and that's what this is. This is a distance formula. When you have an angle or a triangle, you've got to learn the Pythagorean theorem. Pythagorean theorem, let's pronounce that because it sounds awful when you try to pronounce it when you're ignorant. It just don't work. So, P, as in, sorry, Pythag, Pythagorean. Okay? Pythagorean. For some reason I thought there was an A. Anyway. He was the guy, Pythagoras was the guy that actually came up with the Pythagorean theorem, which means if you have a triangle, a right triangle, the sum of the squares of the legs of the triangle is equal to the square root of the hypotenuse squared. C squared. Okay? And that's what that basically says. A squared plus B squared is equal to C squared. So if you wanted to solve it, you take the square root of whatever you want to solve for. You also can see it as x squared plus y squared is equal to r squared. Write those down because you're going to see them in two different ways. In most of your physics applications having to do with radians or having to do with vectors, you're going to see x and y. In most of your mathematic calculations, which will be before trig, algebra, it is a and b. Okay? And that's what that's showing right there. They're showing you basically how to get the Pythagorean theorem. There's the Pythagorean theorem right here. R is equal to the square root of x squared plus y squared. If you solve this for R, you take the square root of both sides, and you get the square root of x squared plus y squared. Again, this should be review. Okay? We just covered this. This is probably your special side. Yeah. We just covered this. We just covered this, I think. No, this is an example. Okay? But I don't want to go over. Wait a minute. Hold on. I'm going to do that one long as I. There. All right, do this problem. What's the first thing you do in any kind of trig or physics problem? Draw it. Draw a picture. Oh man, that stuff works. I'm getting kind of drowsy. Was it Mucinex? My eyes are watering. Evidently, it's knocking all that stuff loose. I woke up this morning, my head felt like a cement block. Felt like Caillou's head. You ever seen Caillou? His head. You know, something wrong with that kid. He don't have any hair. All his friends have hair, but he don't have any hair. Something wrong with that boy. Yeah, that's why my kids didn't watch him. I didn't let my kids watch that guy. My kids watched SpongeBob, and earlier they watched Blues, but they didn't watch Blue's Clues after Steve left. That other guy sucked. Yeah, he sucked. You did? Okay, I need somebody honest, Miss Simmons. Tell me what time class is over, because I don't believe anybody else. What time's class over? And I'll look it up on my phone. Is it 12:35? Okay, y'all have to let me stop at 12:25 because they break down the door and I'm still trying to load my video. So I've got to start earlier. So I'm going to say, you know, it gets old. I don't know why they have people coming into my classroom. I'll have to get on Debbie about that. Yes, she is. Why is she so stressed out? Oh, you are? Why are you leaving? Oh, good for you. She won't be like her right-hand person.
I mean, I'm not on the time. I'll be there.
Is she going to get somebody or what? Well, I'll tell you what. I know how it feels because I'll tell you, it's hard finding somebody that knows how to do it. I'll be honest with you.
I think that's a problem.
That, I mean, it's not just out in the real, I mean, academia, I mean, farm, I mean, it's hard. I don't even fool with it. I don't. Terminal side of an angle, well, it's stronger. First of all, you need to plot the point, -3. 1, 2, 3, -1, 2, 3, 4. Alright, so that's 3. And that's 4. And you put a negative there and a negative there, but it's going to be positive because distance can never be what? Negative. So 3 squared is 9, 16, 25, 5. That should be your answer. Now, I'm going to take this, and I'm going to go over here, and I'm going to draw it like this. Got my handy red marker. -3 here, -4 here, and a +5 here, and I'm going to put my little man right here. That means he's got his foot on the adjacent and the what? The hypotenuse, and he's looking at the opposite. Alright? Now, find the 6 trigonometric functions of that angle. And now I want you to tell me what the angle is. You may not know how to do that. I'm going to show you. It's a trick I learned in the war. It's a joke. That's what a lot of people, a lot of veterans say. It's a trick I learned in the war. So take your calculators out, and we'll go ahead and do, I'm just going to do the sine, cosine, and tangent. Sine is equal to Oscar add, so that's going to be equal to what? -4 over what? Cosine is equal to a hump, which is going to be -3 over what? And tangent of apple, -4 over, which is 4/3. Y'all check me. I'm going to pick the tangent because it's positive. And I'm going to go over here, and I'm going to say tangent of theta is equal to 4 over 3. I'm going to divide by the tangent. Divide by the tangent. Theta is equal to 4/3 over tangent. Now, if I bring that tangent up, what's it going to turn it into? Tangent to the -1. Theta equals tangent to the -1 of 4/3. So you take the calculator and you take 4 divided by 3 and get the inverse tangent. So we take our handy dandy calculator, which I'll pull it up. I'll pull everything back up so I don't have a cow. Hold on. Still want my handy dandy calculator. Make sure it's in degree mode. Pull up pull up this. All right, so I can do this. I can do it this way. Second tangent of 4 divided by 3. And if it's in degree mode, now somebody tell me, well, you're already over 180 degrees. Yeah, it's not in mode. Degree, clear, inverse, entry. And of course that's, so I'm going to see if I can do this. Second answer, math. Where is that? Oh, second angle. 3 minutes seconds. There we go, write that down. Oh, I've been needing to sneeze all morning. So 53 degrees, 7 minutes, 48 seconds. Now what are you going to add that to? Look at your picture. 180. So take 180 and add that to it. What do you get? That's not rhetorical, I'm asking you. How much? I'm sorry. 233, that would be right because this is 270. So it would be 233 degrees and change. Okay? And that's how you find angles, and that's how you find the sine, cosine, and tangent. Now, if you want to, what is it when you don't walk a straight line, meander? I'm trying to sneeze again, I'm sorry. If you want to meander through trig and not have your ducks in a row, then just gap this off and don't learn it. Okay? Then you're going to be sucking air the whole time through trig. This section today is the foundation for the rest of the semester. Okay? If you don't learn this stuff, okay, if you don't learn these basics, then you're going to have a hard time the rest of the semester. So make sure you spend plenty of time on 8.2 homework. 6 trigonometric functions can be found from any point. Okay, I don't really care about that. Okay, they're just showing you there's another angle at -2, or +2 and -1. You do the same thing there. Okay, we'll get to that in a minute. Okay, that's what they're finding right here. Now, let's look at the unit circle again. And I'll pull this thing up. The unit circle, I need y'all to stop me around 12:20, okay? I don't want to have people knocking at the door while I'm trying to get out of here. Okay, let's just take a look at the unit circle. And let's just take a look at the quartiles. Because this is 0 and this is 360. This is 90. This is 180. And this is 270. This is pi over 2. And this is 2 pi, or this is 2 pi. This is pi. And this is 3 pi over 2. Check this. I'm just throwing that up there, but on the unit circle, the coordinates are written in terms of cosine first, right? And those of you who's had it. Okay? So the x is right here. I meant the y. Yeah. R sine theta. Yeah. R sine theta. This is your y. This is your x. That's just the way it is. Don't ask. All right. So if I want to write for 0 to 360 the x and y, well, it looks like to me, and the radius is 1. Okay. Radius is equal to 1. Then what can you say about this point right here? What can you say about this point right here as far as x and y? It what? It's on the x-axis, so that means it has a unit of 1 unit on the x-axis, right? So therefore, if it has 1 unit on the x-axis and it doesn't move in the y-axis, what is the unit for y? 0. Which one goes first? Well, this is cosine, this is x. So the cosine is what? 1. So I'm going to put it right here. And the sine is what? 0, because sine in physics is y. The reason you need to remember that is because a sine, like a stop sign, it looks like a pole, as an eye is a pole. That's how you remember when you get into physics. R sine theta, R cosine theta. R sine theta is your y, R cosine theta is your x. And they're getting into that right now because this is the x and this is the y. All right, now, what's going on with this point? 1 in the y direction, but 0 in the what? Okay, so let's look at 90. Go there. 1 in the y direction, and 0 in the x direction. 180. What's going on here? Well, this x is what? -1, but the y is what? Look here, 180. 0 in the x direction. So sine. And then -1 in the cosine direction. 270. -1 in the y direction. 0 in the x direction, so 0 would be sine. Did I do that wrong? I didn't pass accurate, sorry. -1 and sine is in 0. And 360 is going to be the same as the first. Well, what the heck is with that undefined? Well, what is tangent? Of apple, Hubert. That's right. If it's of apple, and you know that these two right here, this is the x, and this is the y, and this is the x, then you can say this is the adjacent, and this is the what? Opposite. Now what happens when you divide by 0? You get undefined, Hubert. That's right, class. What happens when you divide a number into 0? Again, all you have to remember is just that unit circle. Or node. You need to know. Yes, ma'am.
Okay, so you go on the chart, the sides coming for the cosine, when we write it for it's cosine.
Yeah. Always remember this, and you're going to see it again in your physics and your calculus. X is equal to R sine theta. Cosine theta. Y is equal to R sine theta. Now you haven't been taught that yet, but what they're doing is they're teaching it to you now because you're doing this. When you write the unit circle, cosine comes first, and sine comes second. Why? Because cosine is what? And y is sine. And the way that you remember that is just put a stop sign. Put a stop sign right there. The I, stop sign, y is vertical. That's how I remember it. Since Clemson, that's how I remembered it. Okay? Like I said, you're getting a lot of the basics in this section. So if you need to spend a lot of time on a section, it's this section. All right, do this one. Now this is where your critical thinking comes in. We haven't done an example, just you need to be able to do it by critical thinking. First, draw a picture. And ask yourself, what is the cosequence? You think you got it? The job is make sure that you're discouraged. What you want. Huh? Okay, good. That means I'm doing my job. Okay, sine, cosine, tangent, cotangent, secant, cosecant, Oscar, tab, a, hump, of, apple, apple, of, hump, a, and Oscar. Now, we're given the what? So that means that our hypotenuse is equal to square root of 12, and our opposite is negative 2. How do I know that? There's a reason. The hypotenuse can never be negative. Thus the Pythagorean theorem. Always remember that. That will follow you into Calc 1 and 2. The hypotenuse can never be negative. If you can prove to me it can be negative, then I'll give you a $100 bill. You can't, because Pythagoras has already done that. That's how I knew to assign the negative to what? The 2, yeah. So I draw my picture. Now, if I got a theta anywhere around here, my opposite is going to be the what? The y, Hubert. That's right. So I've got a negative 2 on the y, but I don't have an x. So I'm going to have to use my old friend, the what? Pythagorean theorem. Pythagorean theorem. A squared plus b squared is equal to c squared. A doesn't matter because A and B are legs and they're added, so it doesn't matter where you put it. I'm just going to leave A by itself. A squared plus negative 2 squared is equal to the square root of 12 squared. A squared plus 4 is equal to 12, because what happens to the square and the square root? Okay. So a squared is equal to 12 minus 4 is 8. Well, let's figure out what 8 is. Let's see what we got. You can write it as square root of 8. Square root of 8 is okay, but I don't like that because you don't use that in the real world. So I'm going to change it. All right, so the square root of 9 is 3. The square root of 4 is 2. So 2.5 is in the middle. This is called interpolation. Find the middle of the middle of the middle. 4 to 5 is 2.5, so that's the square root of 6.5 is 2.5. So I'm going to go here. Of course, I know it's going to be right at 2.9. I know that. But let's just go ahead for giggles. Let's just do it. So half of 3.5 is, or 2.5 is what? What's half of 25? 12.5, 1.25. So that'd be 1.25, the 8.25 or 7.75, which would be 8. Square root of 8 is around probably 2.5, that'd be 2.75. I say it's around 2.8. What is it?
It's 2.8.
2.8.
Can we also write that as 2 to the square root of 2?
2 square root of 2 is good. All 3 of these answers is correct.
You'll take
Yeah. Now, you watch your directions because some of your homework questions, remember, you're in academia, so they're going to want these. Real world, that's the answer. But anyway, so I've got an x now. This is my x, right? My x is positive, so that means I'm going in the positive direction. 2.28 or 2 square root of 2. And I'm going down, what? Negative 2. And my hypotenuse is square root of 12. Here's my little man. He's looking at the opposite. He's got his foot on the adjacent and the hypotenuse. What is the cosecant or the sine? So that means negative 2 over what? Square root of 12. Didn't even need the adjacent. But this is how you do these problems. So the future problems you'll know. So negative 2 over the square root of 12. What are you not supposed to have? Radical in the denominator, so that'd be square root of 12. Negative 2 square root of 12 over 12, which is equal to negative square root of 12 over 6, which is equal to 4, which is negative 2 square root of 3 over 6, which is equal to negative square root of 3 over 3. Now, I've got 3 degrees, and I've got degree toward my doctorate. I know there's easier ways to do it. I know that. I realize that. I don't need 18-year-old people telling me that. Okay? I'm just showing them how to get it the basic way. Okay? Let's see what the next slide's got. Okay, thank you. If you learn 8.1 and 8.2, it won't be as difficult when you get into the other stuff. Yes. Oh, yeah, that's right. I'll go over that when we come back. Okay? Y'all just work on the basics. I'll go over that. I forgot. I'm sorry. I suck. Okay? Just go ahead and put it on my evaluation. I suck. All right, next one. Let's see if we did it right. Well, did we do it right? Of course we did. 25. Of course it was. Okay. We'll do this. I'm not worried about this. What?
I did the super simple one.
What is?
I didn't do the adjustment because I didn't just go.
Yeah, that's fine. That's fine. But the reason I went through the whole spiel is because most of the time you're not going to be given that easy a problem. You've got to find the x. Okay, I'll go. This is not important. This is just Okay, this is getting into Pythagorean identities, and I'm not going to get into those yet. God, they already getting into the identities? Okay, we'll get into that. I don't want to get into that right now. Okay. Okay, who has a question? Miss Fuller, are you okay? Maybe she'll talk, but she don't went back to sleep. She's probably drinking and all that. Yeah, she's good. All right, I'm going to cut her off. Now you're able to work on 8.1 and half of 8.2. Do not do the gears and the pulleys on 8.1, and don't go into the ranges of the positives and negatives. Don't go into that on 8.2. Just work on the stuff that I have covered, okay? How many we got today? 4, 5, 6, 7, 8, 9, 10. We're missing 1 or 2. Anybody missing? Oh, Miss Fuller's here. Miss Fuller's here. That's it. Everybody's here. Oh, one's missing. This one's missing. All right, y'all get out of here. Have a good day. See y'all when? Tuesday. And don't come to class Monday. If you got a class Monday, don't come to class. It's Labor Day. Did I turn off that thing? I'm going to make sure it's working. I want to get out of here as soon as I can. Stop recording.